Hello guys, let's continue with tutorial number 9. The other videos, I think we ended on question 8. So just a reminder for those of you who watched the video, the question 7, there was I think the areas were swapped. I'm sure a few of you observed that and were able to contact me. But for those who are still wondering, it's just the areas that were swapped. Okay, otherwise you follow the same procedure when solving that problem. All right, so let's look at question 9 here. So question 9 here assumes that when you breathe in or when you inhale, you have less density than when you breathe out. Okay, now there's this situation here. We have a human who is floating rather above the surface of a water body. So now if this human is floating, then it means the weight of this human is equal to the upward force exerted on the human by the fluid. Okay, so now we want to find how much of this human's body remains above the surface of the water. So what we know here, first we have to consider the weights of the human as well as the weight, the upward force exerted by the fluid. So now notice that the upward force exerted by the fluid is equivalent to the weight of the fluid. The only thing that is different here is the direction. It's acting upward. Okay, so what we mean is that the weight of the human is equal to the upthrust force exerted by the fluid. All right, so now we know also that weight is given as the weight of the human is the density of the human times g, okay, times the volume of the human, and also the weight of the fluid which provides the upward force is given as the density of that fluid, which is water, multiplied by g multiplied by the volume of the water. Okay, now the volume of the water. So the volume of the water here, we are going to consider the volume of the submerged part of the human. Okay, when a body is placed into water, it's obviously going to displace some amount of that water. Okay, so that volume of the displaced water is equivalent to the submerged volume of that particular object. So let us consider this volume of the fluid as the submerged volume of the human. All right, so therefore we need to find the volume, or rather the amount of VH that remains on top of the surface. So now in order to do that, let us first know how much of this body was submerged. Okay, we can easily know the submerged the amount of the submerged volume of this human. Okay, so notice also that g is on both sides, therefore it's going to cancel out, and if we are to make an expression for vs here, we're going to have vs, which is the submerged volume, being equal to the density of the human times the volume of the human over the density of the water. All right, now notice that here we are still dealing with the case in which the human is breathing in. Okay, and when the human is breathing in, it means that the density of the human, this one, is given as this guy here. Okay, we are still inhaling, Therefore, we consider the density of the human as the human breathes in. Right, so let's substitute these values. Now the density of the human as well as that of the fluid are also given. Take note, the density of the water is given here, as well as the density of the human as the human breathes in or inhales. Therefore, we are going to substitute those values, and we have the density of the human is 945 over the density of the water 1030 multiplied by the volume of this human. Roughly, this is going to give us about 0.768 multiplied by the volume of the human. Okay, so when we look at this, okay, let's just move on to need some space. When we look at this, it has given us that the submerged volume of this human is equivalent to 768 V, okay, VH. Okay, so meaning that the submerged volume is roughly about 76.8%. So this is the amount of volume of this human that is below the surface of the water, but we want to find the amount of the volume that is above the surface. All right, so we simply substitute this. If we consider the total volume to be out of 100%, then it's going to be 100% minus the submerged volume, which is 76.8%, and that should give you the percent of the amount of volume that is above the water in terms of percentage. Okay, so when you do that, you're going to realize, or rather find, that the volume of the human that is above the surface is going to be about 23-ish. What is wrong with my 3 today? 23.2%. Okay, so only this amount of this human body is above the surface of the water. Okay, the rest, which is 76.8, is actually below the surface of the water. All right, now let us consider the case in which the human is actually breathing out. So we are told that when the human is breathing out, the density is actually higher. Okay, so let us see. We know that the density of the human multiplied by G times the volume of the human equals the density of the water times G times the submerged volume, or rather the volume of the submerged part of this human. Okay, so again we take out the G, meaning the submerged volume. The submerged volume of this human is given as density times its volume, which is the total volume, over density of the water. So now the density of this human when he's breathing out is given as 1020 kgs per cubic meters, and the density of the water is still the same, 13 multiplied by VH, giving us the submerged volume of the human as 0.829. So I'm going to round that off, which is going to give us  times VH. Okay, this implies that the submerged volume of this human is roughly around 83. Okay, let me see. 83%. Okay, so this is a rounded off figure. So this is the amount of the human volume that is actually submerged. Okay, so now we need to find the amount of the volume which is above the surface. We are simply going to subtract that from 100. Okay, we subtract that from 100, and we're going to have that the volume that is above the surface being equal to 100% minus 83%. Okay, so that should give us a percentage of about 17%. So this 17% is the amount of volume that remains above the surface of the water when this human is exhaling. Okay, so when he breathes out, 17% of his total volume remains above the surface of the water. All right.